So let us now start with the next topic, that is fetch, decode, execute cycle, which is performed by the control unit. Now for any instruction we need to execute, any instruction follows these three basic stages for a particular instruction to execute itself. What is this? Fetch, decode and execute. Now what do you mean by fetch? As I have already told you, the process of bringing the program from the secondary storage device to the main memory in order to execute itself is called as fetching. Now what do you mean by decoding? Decoding is the process of converting the high level language in which the programs are written to the lower level language, which is in the forms of zeros and ones, so that the computer can understand it, is called as decoding. And the execution is the execution of the program itself. So in this particular diagram, if you can see, the first stage is fetch. Now the instruction is fetched into the RAM. From RAM, the required data moves to the registers, which is located into the CPU, wherein they are decoded in the form of 0 and 1, and ultimately they are executed by the ALU. So this is, and again if they want to execute the second instruction, the same process follows until the entire program completes its execution. So let us see the basic registers into it. As I've already shown you it in the von Neumann architecture diagram, there are various registers, which is AC, PC, MAR, MDR, current instruction register. Now as I've told you, accumulator. AC stands for accumulator. Accumulator is the register which is used to store the temporary results which are performed by ALU. Let's say for an example, if you are performing addition, let's say you are performing addition with the variables a plus b, value of a is 2, value of b is 3, obviously the result will become 5. This 5 will be temporarily stored in this accumulator. Then there is program counter. This program count, I will show you the simulation in the next slide of how this register works. For time being, you just understand the purposes of these registers. This program counter will currently, at the initial stage of the execution, it will store the address of the memory location from where we have to start the execution of the program. Let us say we want to start the execution. The program is stored at 000H. So currently PC will have the value as 0000H. Why? Because it has to start its initially it has to start its execution from that particular memory location. Once the program has started its execution, it will increment itself by 1. So again, when the first instruction is fetched and started its execution, again it will be incremented itself by 1. So this is the program counter. Basically, it will show the address of the next instruction that needs to be executed. Then we have memory address register. Memory address registers will store the address of the memory locations that needs to be accessed. Memory data register. Memory data registers are the registers which will store the data which is stored at a particular memory location. Then we have current instruction register. This current instruction registers will store the address of the current instruction that is being executed. Now this is the simulation that I'll be showing you of how the data is stored into the registers. So these are, as I've told you, PC, MAR, MDR are the registers that are stored on the CPU. Now these are the memory locations. If you see 2000, 201, 202, 203, all these are the memory locations of the main memory, or we can say RAM. And at this particular memory locations, there is some data stored into this particular memory locations. Now, as I have told you, PC will contain what? It will initially contain the address of the memory location from where it has to start the execution. So what does PC have right now? It has 202. So it will move into MAR. What is MAR? Memory Address Register. Memory Address Register will have the contents of PC. So it will have 202. So at 202, it will move to 202 via the address bus. Now at memory location 202, what is the data stored? The data stored is load 205. This load 205 will be passed with the help of the data bus to MDR, as MDR will store the MDR is the register, that is memory data register, which will store the data that is stored at the memory location 202. So the contents of MDR will be the data at memory location 202, which is now load 205. This data will come here. Now what MDR what is the contents of CIR? Current instruction register, which means what? Whichever instruction will be executed currently will be stored here. Now this instruction load 205 is in a assembly level language written. Now this needs to be decoded and executed. So this decoding and executing will be done in the CIR register, that is current instruction register. Now once this fetch cycle or this particular instruction has executed, program counter will increment itself from 202 to 203. Now now again this 203 will be contents of MAR. Now this 203 will from the address bus it will move to 203 location. At 203 location, what is the data? Store 201. So to store 201 will come from the data bus to MDR, and again this store will be moved to CIR. So in this way this particular execution of the particular program will be completed. I hope you understand this concept, because it is a very important concept, because we will be requiring it in the further lectures as well. So the summary of this particular session of von Neumann architecture was that the von Neumann architecture was able to store the program as well as the data in the same memory unit. This means obviously it was easier to modify and re-execute the program. It needs control unit, ALU and registers for the execution of the program. Fetch, decode, execute cycle carried out by the control unit we learned. Then we also learned about certain registers that are there in memory and how they communicate with each other in order to execute a particular instruction. Thank you everybody.